this last measurement video is just some other ideas that may help you in your studies. We've got to find the volume of a lake. The average depth is 2.4 metres, and each of the squares on this grid is 1 centimetre by 1 centimetre. So, and we've got a map scale that's 1 to 1,000. So that means that our 1 centimetre on the map is equal to, or equivalent to, 1,000 centimetres in real life, which is 10 metres. So that means that one of those squares is 10 metres by 10 metres, which is 100 square metres. So what we need to do is go through and count how many there are. Now we've got some whole squares and we've got some part squares. So I think the first thing is to count the whole squares. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's only a tiny fraction missing from this one, that won't matter, 21, and only a tiny fraction of this one, 22. So basically, the number of squares that we've got is equal to 22. Now let's make a starting point and work out how many more there are. So we might start down the bottom here, and this and this, just a little bit under a half. If we rate those as about a third each, we could say that those three together are equal to 1. So let's just add one more, and let's go to another 3, like these 3 here could give us another one about equal to one more full square. Now this one here, we've got just a tiny bit, we've got another tiny bit, we've got this one which is probably about half, and then we've got these two parts here. Look, this one's fairly awkward, but we could say that this one and this one and this one and these could perhaps add up to one more. Okay, let's keep going. We could have this one and this one, and a little bit there could add up to another one. And then we could have, I think that these two could form another one. And then we've got these could make another one. And then we've got, we'll go, still got a half here roughly and a half here, so let's make another one out of those. And then let's, this one's nearly 3/4. This is I'm just thinking this one, this one and this one will be too much. I think these two could make another whole, which leaves us just this one left, which is about a half. Now that whole process is not an exact thing, but it will give us some idea. So let's see how we went. 22, 23, 24, 25, 26, 27, 28, 30. So we think that's about 30.5 squares. And so we know that the area is going to be 30, and I'll go to decimals now, times by 100, because we know that each square from what we worked out in here is 100 square metres. So that is about 3,050 square metres. So that puts the volume of the lake. We're treating it like a prism now. It's got a certain depth, so this is the cross-section end, and the depth of the or the height of the prism is 2.4, so it's A times H, which is 3,050 times 2.4, which is going to come out at about 7,350 approximately. I need to add I'm not quite using a calculator here. And that's cubic meters, which, remember we said before, is 7,350 kiloliters, or we could say that that is 7.35 megaliters. Okay, another idea. We want to calculate the area of the Tasmanian mainland. Now, I don't have a scale to this map, so I've just taken direct measurements, and I've made this strange shape here. So you'll notice that along any side there's some sea, and there's on one side of the line, and on the other there's some land. But generally speaking, that's the shape. And you'll notice that that's a trapezium. Okay, these are our two parallel sides, and our height here is 330 kilometres. So that means that our area is a half A plus B times H, which is a half of 300 plus 80 times by our height is 330, which is a half times 380 times 330, which is equal to, I can do the half bit in my head, so that's 190 times by 330, so 190 times 330 is equal to 62,700 square metres, or sorry, I need to rub that out. That's square kilometres. And if you research this answer, it's approximately 64,000 square kilometres. So this is one way that you can do an estimate, is to take the shape and apply some basic shape to it, or a mixture of basic shapes.